Here's an alternate form of problem 4129, a little bit longer form, if you will. We have this probability density that's a function of x. And we can see, as we see it graphed, that it is linear. So it's of the form mx plus b. In fact, the slope is going to be rise over run, a squared over 3x plus y-intercept in the interval of -3 to 0. And it's going to be equal to a negative a squared over 3, a negative slope, x, plus y-intercept a squared, in the interval from 0 to 3. So that would be our function. It's going to be 0 everywhere else. So if we were to calculate the probability density and integrate that over everywhere, that should be equal to 1. And in this case, we're going to end up with the integral from -3 to 0 of a squared over 3x plus a squared, all this dx, plus the integral from 0 to 3 of negative a squared over 3x plus a squared dx. All this should equal 1. Alright, so let's factor out an a squared out of everything. And we're going to end up with 1 plus 1/3 x dx, integral from -3 to 0, plus from 0 to 3, we're going to have 1 minus 1/3 x dx. And all this should equal 1. So if we integrate that, we're going to end up with a squared times x plus 1/6 x squared, evaluate from -3 to 0, plus x minus 1/6 x squared, evaluate from 0 to 3. And that should equal 1, all that. So this will be a squared times 0 minus x plus 1/6 x squared, so that's going to be 0 minus a -3 plus 9/6 plus 3 minus 9/6 equals 1. So that's going to be 3 plus 3 minus 3. So it's going to be a squared times 3 equals 1, or a squared is equal to 1/3, or a will be plus or minus 1 over the square root of 3. And since we're looking for a squared to equal 1/3, it doesn't matter whether it's plus or minus. Either one will do to give us an a squared equal to 1/3. So in this case, we can choose either -1 over the square root of 3 or +1 over the square root of 3.